Welcome to part 2 of the follow-along Unity project. In part 1, we got our core gameplay working. I moved my character and I thought to myself, is this fun? And because I'm making a puzzle game, I didn't have a good answer yet because I haven't done level design. But if you're making a game that's not a puzzle game, we make level design, that you should be playing with your level and deciding if it's fun or not. Now, I've made a similar game to this in the past and I have a pretty good sense that this is going to be all right, or it could be all right. So we're going to keep going. But usually this stage of the project is where you need to be able to answer, is this fun? As soon and as early as possible. And that's sort of how we define that alpha stage of our prototype before doing the things we're going to do in this part 2, which involves actually being able to move between levels. So we're going to move on. We're going to take our player movement, and we're done with that. Delete that. We're going to take our pickups, and we're done with that. Time to work on getting to the end of the level. And then input to movement, we did that. Level manager, we need to make a UI for moves left. And these are going to be like you hitting your head, you know, like how many buttons you can press. So we need to manage moves. We need a win state and a lose state. And that's going to be, all that's going to be in some kind of manager, right? So we're going to need some kind of manager to keep track of the winning and the losing of the game. You can lose when you go into some death area, which we're not going to implement, and you can lose when you run out of moves. We want to do a restart game. We're going to write 2 managers. We're going to write a level, maybe 3 managers. We're going to write a level manager, which is just going to be, it's just going to handle the, I go to next level, I go to previous level. That's its deal. It deals with that. I restart the level. That's its world. We're going to use scenes for that. I'm going to go to the next scene, previous scene. What is the list of scenes? So on. And then we're going to have the manager, the game manager, keep track of, has the player won? Has the player lost? Should I show you win on screen? Should I show you lose on screen? And so on. And then we're going to have a UI manager that's going to be told what to put up on the display. And it's going to tell all the UI stuff to put that stuff up on display. You're going to see some patterns that as we go in the future, we're going to learn some really clever ways to replace the patterns we're going to use today. So I'm going to be writing code that I wouldn't write in a real world situation. And I'll make sure I let you know, like, hey, take a note of what parts of this are annoying and what parts of this work well. But we're not going to use any scriptable objects. We're not going to use any super advanced stuff. Scriptable objects aren't advanced, but it's just like another set of knowledge we don't have. It's practice. So. But first, the in progress thing. What did I say? The current in progress task is level end. Is how do we get to the end of a level? All right, so we have a pickup. Let's turn that into a prefab. Let's throw that down here. And I'll take that out of my scene. And let's make something that defines the end of our level. Some square. Oops. Level and goal. And if you reach this goal, then you've won. And we'll make it a color. We're already green. Okay, purple. Obviously need to change this prototype art. My game is not playable if you're colorblind. So how are we going to check if the player is on top of this position? That's an interesting question. The answer is we've already written that code with the interactables. Curious. So I don't want to repeat myself and have the player run another script where they check for interactable and then another script like check for at goal, and then I check for at, and then because as I scale my game up, I want to add a new feature. I want to add power-ups. I want to add potions. I want to add all sorts of things, and they're all checking if we're overlapping something, and I'm already doing that. How should we make this work? Check for at goal. So we don't want to do that here. we want to just use this interactable. Now, the answer, of course, is an object-oriented hierarchy, but that's next week. And we're going to use this project, and we're actually going to replace this part when we cover that. So let's do it the component way, the Unity component way. We're going to make interactable, when it gets interacted with, look out to see if it has a goal component attached to it. And if it does, it's going to call the goal. It's going to tell the goal component that the games that you want. And it's going to tell the, it's going to see if it has a pickup object, and it's going to tell the pickup object to do its logic as well. So we're going to be able to, we're going to turn the pickup, we're going to turn these other components, and then the interactable component will call along and will tell those what to do. There are some ways we can do that. We can do that with Unity broadcast events and messages, which might be very clean. But I want to practice some of our, and that's like not as performant. I want to practice some of our logic just so that we have the stuff that we're going to replace in the future in a future lesson. So we're going to make two new components. And they're both going to be, we're going to think of them both as interactables. On the interactable, we're going to add a new component called pickup. And now, if you were curious why I was like switching between those words in the previous video, it's because I knew we were doing this, and I'm thinking of the pickup as a type of interactable. I'm thinking of the level end as a different type of interactable. Pickup, and we will take our, whoops, I took that into a prefab. I do want it in my scene. And we will take our pickup, and we will give it a pickup script. Next, we will make our level goal. We're going to give it a box collider. We're going to put it on the interactable layer. We're going to give it an interactable script. And we're going to give it a end goal. Goal. And we're going to give it a goal script. So both the goal script will be looking for the interactable for this event to happen. And the pickup script will be looking to the interactable for this event to happen. Which, when in the future, when we learn about event systems, we're going to be like, ooh, okay. And it's going to be great. But we're not covering event systems today. We're just making this follow along video. So we're doing it kind of the quote unquote hard way. Not that hard, but you're going to see why this is annoying in just a second. I love it. Okay. Our interactable will have a reference to our goal. Underscore goal. Sorry, I'm looking at the wrong computer monitor, and there was like a slight delay of like my recording preview and my. Okay. And it will have a pickup underscore pickup. And then let's open those scripts. And on pickup, we'll write a public void pickup function. Let me fix my thing here. On our pickup script, we'll add a pickup function, and it will destroy itself for now. And our goal screen will write a public void player at goal. And that's fine for now. And our interactable will initialize. We're going to get references to both of these components. The objects in our scene that are pickups won't have a goal component, and the objects in our scene that are goals won't have a pickup component. So these could be null. So what we want to do is check if our goal is null. Is not null. It's the opposite of what I said. If the goal component is not null, then goal dot player at goal. And it could be both. It could be both. So I'm not going to do an else. If our pickup is not null, then our pickup dot player, is that function not public? Public void pick up. I got a package. Cool. Now you know the video is going to be short because I want to go check my mail. Okay. Let's pick up 1 word or 2 words. It's not, whatever. Name the variable, name your functions better than me. Note to self, rename this. Okay. And now you start to see the problem, which is I want to add more things in the future that I interact with. Well, at least for the player movement script, I'm not adding all this code and it's getting more complicated. The player movement script is still just going to do what it does. It's going to tell this interactable function to interact. The interactable function is now going to handle broadcasting this message, this event, to all these different scripts. So the solution to this is one of 2 different ways to do it. The solution is using an event system where the pickup says, hey, if anyone's interested, the player hit here, and then whatever is listening to the interactable just says, okay, and we don't need this big chain of if-else statements or if statements. And the other way to do it is to have an object hierarchy, an inheritance. And I really like this example in this project that has this situation because I like us seeing the way, like seeing the types of workarounds that we, seeing why that this can get messy, right? It would be annoying. Every time I wanted to add a new functionality to my game, I would need to go back to the script and add changes to it. And eventually this if thing might get kind of long and our level might take a bit longer to load on that first frame. So it's worth paying attention to, right? But it's kind of the point of this project is to do some things very cleanly and nicely. This is the manager we're going to get to. And some things we're like, note to self. I don't want a bunch of statements. But this is like a perfectly working solution. Let's go to our goal and add a little debug message. Debug.log player goal. So this has one problem, which is if the goal is in the middle and the player could go through it, the goal got deleted. In the console, player at goal, it works, but my interactable still destroyed the object. But I don't want to destroy the goal object. I just want to destroy the pickup object, and it can destroy itself. Okay. So I took away that. All it does is call those functions. Player at goal. Nice. That's annoying. I kind of want to make an empty parent transform for that, but it's fine. Okay. Maybe I can make them. No, it would cause, if I made them children of the player, it would cause a bug. Okay. So now what? Now we need to actually manage our game. I want a game manager that keeps track of when I am at the goal and then can display some text on the screen. Hey, you win, and stop my player from moving. So after I win, I can't keep running and I can have time where the player will interact with text. I could also have a lose state where I run out of lives and I want to track how many lives I have. All of that is going to be involved in the manager. Did I close my... hold on here. Okay, I'm recording it. Yeah. Level end, done. Restart game, move state, manage moves. All of this is going to be in a manager. It's going to be in the game, one single game play loop. It's going to be managed, right? Level manager we'll go to next. Moving to another scene we'll get to next. But first we can track all of this in one place. So we're going to make a new empty game object and we're going to call it game manager. I like my empties to be zeroed out. Okay, let's make a new script. Game manager. Now, this looks like a gear icon. What's up with that? Well, it turns out using the script of game manager is pretty common. So Unity gave us a gear icon for managing scripts. Thanks, Unity. It's still just a script. It's fine. But we got a little gear icon and I can add my game manager script and I got a little gear icon. It's the thing. It's helpful. It was more helpful back in the day, I think, in Unity, but now that we're implementing all the logic ourselves, it's like we're not in Unity version 3. I've never used version 3. I don't know how it worked. But. Okay, so what does the game manager do? Well, it keeps track of our number of moves. A number of moves we've taken. So every time we move, we're going to need to tell the game manager that we have moved so it can add 1 to the count. Or no, subtract 1. We start with a set number of moves and then we lose a move each turn. So private int moves taken. I like counting up if we can count up infinitely, and then I can just compare it to another move and we can display it counting down. Does that make sense? Yeah, moves taken. And that will be private. We'll do a little underscore so all my private function variables are private. And I will write a public function for take move taken. Take move. Move. Turn taken. And we're going to call them turns. Turns. What am I typing? Move taken? Take number of... I confused myself. If I had coffee, you just take a sip of coffee. Private int number of moves the player has taken. Number of... I'm going to choose turns. Turn count. Turn count feels good. Turn count feels right, and we're just going to stick with it. We take a turn. Turn count plus. Excellent. That seems good for me for now. Because now we need to call this function from the player movement class. Because that's where we moved. So we need to call that function, which means we need a reference to the game manager. So let's go to player movement. And let's make another serialized field, private game manager. Game manager. Hey, look, our code's starting to look a lot like a regular Unity script. We have our game manager. We're going to edit it in the inspector, and it will run. And when we move, we will do this function. It will recursively repeat itself over and over again until we're at the end. And then I will paste something silly, and then I will go to the game manager and turn taken. And we'll do that. Maybe we could do a turn started or something if we need to. But there we go. So how do we have the player know the game manager? Right now, I made that serialized. Let's make the player a prefab. Player, drag, drop, they're a prefab. I can make changes. It's asking for a game manager. Well, that game manager's right here, and I can drag and drop it and put it on that slot. If I apply this to the prefab, I'm going to get an error. A reference to an object in the scene cannot be applied to a prefab. Interesting. And that's because I'm going to have a number of different scenes, and each of them is going to have their own copy of Game Manager. Interesting. So I can't set it up ahead of time. I will have to go to every single scene I create and drag and drop the Game Manager into this slot. And that's fine. It's actually not that big of a deal. Developers do backflips to avoid having to do this, and it's not that big of a deal. Especially because we can click the little gearbox, and it should be only one option, and we should just be able to hit enter gearbox, the little bullseye selector, and be fine, right? But, sorry, down enter, be fine. But we're lazy developers. Let's get rid of that serialized field. Let's not drag and drop it. And let's write in, are we using awake yet? No. Let's write a awake function. And on awake, we're going to set game manager equal to something. What are we going to set game manager equal to? Good question. We're going to set game manager equal to aimObject.find. And don't type this. I'm going to change it in a second. The find function searches through your hierarchy and looks for a it looks for a game object with a particular name. And it can find that game object and return it. And then we can do a get component call on it. And that would work. But then if we renamed it, then our code would break. And that's bad. We don't want to use strings to do anything like that. So we're not going to use find. Instead, we're going to use find object of type. Find object of type. And we're going to give it a game manager type. It will now search through all of the components of every game object in the hierarchy until it finds one of the game manager type. And once it finds whatever the first one it found is, if we have 5 game managers in our hierarchy, I'm not entirely sure which one it's going to find. But if we can make the assumption that there's only one manager in the hierarchy, then I'm going to find the same manager, and that's important. And now I can do that automatically. And I don't need that game object dot type. Find object of type, game manager. So I'm going to have Unity, right when I click play on Awake, before anything else happens, I'm going to have Unity go out and find all these references and figure itself out. So my player, the references is null, but once I hit play, we have it's not using the reference anywhere. Or yeah, it is. It's taking a turn, and I just moved, and I didn't get an error. I didn't get a null reference exception where it's null.takeTurn. What do you do? So I made a weird noise. I'm sorry. So it worked. Debug.log turn taken. And I can prove it worked. We open our console. We should see the word turn taken appear every time we move. Turn taken, turn taken. Player echo, and then our last turn was taken. Interesting. It's important to pay attention to the order that these things are happening, right? We collide, we check for overlaps, we finish our movement, and then we tell the game that we've ended our turn. And I think that's a good way to do things because that allows the game manager at the end of it to say, okay, have we run out of lives now, or do we still have one left? And this will, if we hit the goal and hit the wall and have our last life taken, that goal will happen first, right? Player is at the goal happens before we lose our last life, even though we're losing it, should the game get that far. So let's make a serialized private int for allowed turn count. No, how many moves we are allowed to take? Allowed is a weird word. Lives, hearts, helmets. Maybe the game is just about hats. Lives and turn count. And we'll just have that be set to some 5. I don't know. We'll have that set in Unity in the inspector. I think it's probably already equal to 0. Yeah, 0. Okay, so. Cool. So we increase our turn count, and then if our turn count is equal to lives, if I've taken 1, 2, 3, 4, 5, 6, right? So for our first turn count from 0 to 1, second turn 2, 3, 4. So it should count the number of times we've moved. So we have 6 lives, we've moved 6 times. Debug.log game over. Let's just see that happens. 5 lives. One, 2, 3, 4, 5. There we go. Turn taken, turn taken, turn taken, turn taken, turn taken, game over. We lose. Excellent. We'll take that debug message out because it's annoying. That's okay for now. We're going to do the UI to show that up, and we're going to have this change into mean something in just a moment. But first, let's have because this is our we lose. This is our I've lost, right? But let's also add the I've won part of the code here. And once we have I've lost and I've won, then we can manage those states, those possible conditions the game can be in. So we'll make another public function and on the manager, and player wins. Player wins. Player win. Win is a good function name. Debug.log. Won. We won. Haha. Okay. So our goal is now going to do the same little game manager find thing that the player did. So we're going to have a private game manager. We're going to, in awake, set game manager equal to find object of type. There's two here. There's find objects of type and find object of type. We want find object of type singular to just find the first one. And then game manager dot win. And we can get rid of this debug statement that was sort of being a placeholder. So now we're going to see if that one text appears, that we have that message going from this thing in the scene to our manager without me needing to drag and drop anything in Unity. Let's see. 1, 2, 3. We won. 4, 5, 6. We lost. That's interesting. I can't win and lose at the same time. 1, 2, 3, 4, 5. I won and then I lost. Ooh, that's dangerous, right? I'm going into this. I need these things to check for each other. So we're going to manage that with a game state. So we're going to keep track of what state the game is in. And if we are in the won state, victory state, then I will not let us lose. If we are in the lose state, then I won't let us do anything else like move or whatever. So the secret to that is asking ourselves the question, how do we keep track of what state we're in? Well, states themselves don't mean anything. They're just like a label. And I can ask the game manager if something is equal to some label, right? So I could store the state, hypothetically, as a string. And I could check if it's equal to victory. But then maybe I check and it's equal to like victory. Why are you giving me an error? And then I check if it without the exclamation point. And it's string comparisons are super slow. That's really bad. So you're smart. You're going to use an integer instead. And then 0 is playing, 1 is lost, 2 is won, 3 is paused. Right, we can have a little indicator of what this value is equal to. If it is equal to 1, the game is lost. If it is equal to 2, the game is won. And that's fine because it's very fast. We can check integers and see if they're equal to other integers really quickly. But it turns out stinks, smelly, because it makes the code very hard to test. Game state is 2. If our turn count is equal to our lives, and game state is not 2. Okay, game state equals 1 is lost. What does this mean? If you're looking at my code for the first time and you look at this, and I have maybe a much longer script with tons of things in it, you look at this and you go, what is that? And you scroll up and you read my comment and you go, okay, 2 is 1. And you scroll down and you go, okay, and 2 is not, okay, if we have not won already, we can lose. Annoying, dumb, bad. I need some way to define a variable that just sort of has some meaning that is readable, but basically just behaves like a number, where I can just compare if it's equal to a value or not. We have such a thing exists in the world of C#, and it's called an enum. Enum stands for enumeration, I think. I'm actually not sure about that. That's what it feels like. I'm going to go into Writer, and I'm going to add a class. I have an option for enum here. And that's what we're making. We're making a game state enum. I could make any of these other things because enums are the simplest of all of our stuff. Let's deal with namespaces later. Public enum game state. I have an entire file called gamestate.cs, and it is just a thing of type enum. That's its name. Curly braces. What do we put here? Well, comma separated strings. That's it. Secretly, these are going to be numbers. Behind the scenes, these are all going to be integers, and by default, they're just going to be counters. You can set them manually, which is nice if you're switching from an integer system to an enum system, and you can kind of like have halfway refactored code. And for other reasons, it's nice. You can check if it's like bigger or smaller than a number and use that to like group states together. But for us, this is just going to be some flag. Playing one lost. Now, we go back to our game manager, and instead of an integer, we're going to make a object of type game state. And now, when I win, I can set game state equal to game state dot 1. I won. I can, on the turn taken, I can set game state equal to, and game state is not equal to game state dot 1. That I can read. I can read this. If our number of turns we've taken is equal to our total lives we're allowed to have, then, and we have not won, then game state equals game state dot lost. How cool is that? And then in start, we can initialize this by setting our game state to playing. Or we can just initialize it when the object is created by setting it up here. But doing start. Why not? Whatever. So that we can make an event system that updates anyone listening to the thing, which we're not going to do in this project. So like the advantage to start or there is non-existent for this project. Okay. Oof, okay. Ignore those last two sentences. Take a look at enums. I can now just say, what's my state? I can read that. That's a word. That's a word in English. When C# compiles this, it basically turns it into numbers, and it uses it. We've already used enums before. We've already used enums in this project before. Their key codes are an enumerator. All of the different values here, it's just some number. When we my game state, if I make my game state public, so it appears in the inspector, it's going to show up as a drop-down list. Oh my gosh, I love it. And now that it's in the inspector, I can see it, and I can like use this to help me debug. Okay, I'm playing. Oh, I won. And now we can check if that other statement works if I go too many times. I won, right? I went 5 times, but I still won. And now I can see if I lost. Now, even though I lost, I can keep moving. We don't have anything on the screen saying you win or you lose. So we're going to have some other functions, and we're going to have them check the game state. So let's have the player do that first, because the player already has a reference to the game manager on the player movement script. So we can check if underscore game manager dot game state. Actually, we can't do that, can we? We need to get the game state from the game manager. And even though it's nice to make that public in the inspector, I want that to be private. If you're going to change my game state, you better change it via code. That way I can do these if I can check what state we're already in, and I can have all that logic implemented. So I'm going to make a public game state function called getGameState. That's going to return my game state. And And then just for example, I'm going to write I can't type. Lose. So if we run out of lives, we should lose. But we can't lose if we've already won, right? We can do that safety check here in this function. So, and that's why we're using these public functions to control whether or not to change what our game state is and not changing it from other code. Because our game state can work, we can make updates to it, we can add states to it, we can change all sorts of fun logic on the game manager that will make our game easier to edit in the future. And our game state, no one else needs to gets to mess with it. No one else can change the game state. That also will make life easier when we, in the future, want to use an event system to broadcast that our state has changed. So to get around not having that be public, we'll have a function that tells us its value, which is a simple way of doing it. So now in player movement, I can check if game manager dot get game state equal to game state dot one. Sorry, dot playing. And if we are playing, then we will have this game happen. And if we're not playing, then nothing. Nothing will happen. It just won't move. It'll get told to move, and it just won't. Yeah. Loading, loading, loading. Game over. I can't move anymore. That's good. You don't want to be... and then on victory, I win. And I can't move anymore. Excellent. Excellent. So now we still have that problem of moving through the victory condition. We want to end it there. So we could do this check in here instead. So it will get to the victory state and then it will just stop there and it won't move through us. And that's a future bug fix, but I'm not going to fix that bug until I see it in the game. Yeah, because I just don't want to, just to keep the video 3 minutes shorter. Okay. So now our game manager is keeping track of things. We have a win state. We have it. We have a lose state. We have it. We are managing our number of moves. We run out. We have it. But we need UI for that. So we also need UI for moves left. We need UI for won and UI for lost. So let's take a trip into the world of UI. Canvas. Canvas. Did you hear that? My stomach growled like a cartoon character. Ooh, I'm getting hungry. Wild. Okay, on our canvas, let's add we'll just do a very simple UI text. We can do text mesh pro. Oh, it's going to make me do text mesh pro because I'm in 2021.2. It really wants me to stop using the old system. But when I click this button, it wants me to import this. And I don't like sitting here while progress bar goes. Okay, that was pretty fast. It's fine. Okay, let's add a new UI panel, and we'll call this panel victory panel. And it'll have our victory, our text as a child of it. Should have done that in that order. And I'll fade the world green. And I'll take the text and I'll say win. And then I will have a lose panel, and I'll fade the panel red, brown, poop color. Why is that so Oh, the green is also fading with it. Okay, well, if I turn off the victory panel, that's the color it will be. Lose panel, and I'll add the text lose. Okay, and I'll turn that off as well. So I need something that's going to turn itself on and off depending on what the game manager is doing. So we're going to write a UI manager. Let's add a script. Let's add a new folder in our scripts folder, call it UI, and all UI stuff will go in the UIs folder. And we'll write our script, call it UI manager. And now the manager can deal with all of its stuff, including turning on and off, enabling and disabling the various game objects that respond to the state. So we're going to write we're going to keep track of our game objects, because that's what we're actually enabling, disabling, not their text components, not the image component. We're just going to actually just enable the game objects. We'll call it lose panel. Call it panel just because I know it's a panel, but lose game object. Win panel. And we're going to do the same thing as before. Private game manager. In awake, we're going to set game manager equal to game manager and equal to find object of type game manager. Same code that we did elsewhere. And then we're going to write a little function. We're going to call it refresh display or check state. Check state. If game manager dot get game state is equal to game state dot lost underscore lose panel dot set active true. We're using a conditional to check a thing. Yeah. There are better ways to write this code. But we're just gonna do it. Lost, won, and playing. And in our, okay. If our state is lost, then our lose panel is true. If our state is won, then our win panel is true. If our state is playing, then our lose panel is false, and our win panel dot set active false. And I want to do that for all of these, even though they should be going from false to false and it shouldn't do anything, just to like, if I go from winning to playing or so on and so forth, or in the future, if I had a pause state that I can go back in and out of, it'll just set everything as needed on any state it checks. Gosh, there's a better way to write this code, but the other better way to do it is an event system. Because I need to know when to call this function check state. We can do it in update. And we will for now. The game manager doesn't need to know anything about the UI. UI can be deleted and the game manager exists. So we'll put the UI manager on the canvas object. Pretty common to put put that there. If you're searching for managers and you can't figure out why the UI is on some other project, Canvas is a good place to do it. And we hit play. And our object should be inactive. And we win. And our win screen appears. And we can no longer move. And we lost. Feels like it's a little laggy. It's like a pause there. I don't know. Probably because we're doing a lot in that. We're like doing a recursive function. I don't know. I mean, we need to refactor this code to clean it up and to not check this state in update and like change these things every frame in update. We only want to change the state when this information changes. And to do that, we're going to use an event system that we're going to learn in the future. So this is the tough part. This if branch, yeah, we could definitely fix that. But the fact that we are doing it every single frame when almost all the time that information doesn't change, that's the real tricky part. The solution, if you're curious, one solution is to flip our dependency around. So the game manager tells the UI to update, and then the UI, whenever it changes, so we go in and we go UI.update in that code, we go in and we do UI.update in that code, and we go in and we do UI.update in that place. And that's weird. So then we write a function called change game state, and we give it the new game state, and then we can generalize that. But we're going to replace all of that with an event system in the future. So enjoy the badish code. I really don't want the game manager to be dependent on the UI manager. I'd rather have the UI manager be dependent on the game manager, which means it needs to stare at this information and track it. If we could optimize it by storing a version of the state and then only checking for changes, and only when it changes do we actually talk to these objects. But we're just going to leave it simple for now, because I'm at 50 minutes and I'm going over time of my goal, right? Because we got to do some other stuff to get the lives to appear on the screen. Okay, let's add a new UI panel, and let's call it playing panel. And this one we don't want to have an image. It's just an empty, basically just an empty playing panel. And this is like our HUD, right? And this is gonna have a UI panel. We'll call that the HUD, and we'll move this to. Oh my gosh, we haven't gone over UI, have we? Bottom, where should our lives be? Top left at position 0, 0, x 0, y 1, so that our position can be 0, 0, and then we can move it around. Oh, you didn't follow that at all. Okay, I made a HUD panel. I clicked this icon and I changed that to be anchored against the top left. I set my local anchor, the position in my square rectangle that I care about, to be the top left. And I know 0, 1 is a weird top left, but bottom left is 0, 0. So top left is 0, 1 relative between 0 and 1 by pivot point. And that changes where I am, what these values are. So I can change my width and it will scale away from the top left. You can not do any of that and just move it around manually in the scene. And that's fine too. So I want it to be thin and wide. So this is going to display my number of moves left. So let's just add text. We're going to replace it, but first let's get the data moving around. Text. Lives left text. Lives left. 0. Okay. And we'll go to our UI manager. And this script is only checking for the state stuff. So let's just, I'm going to replace this code with icons in a second. So, we'll get a reference to the TMP underscore text object, or text mesh pro text object. Call it lives left text. And just temporarily, we'll just type lives left text dot text equal lives left plus game manager dot. We can't get the number of lives we have left. Let's go to our game manager and make a public function that returns an integer. That gives us the number of lives we have left. And we'll return lives minus turn count. Our total number of lives, which we never change, that's just a set value for the level, and our turn count. Lives left is that. Cool. So now in update, not a great place, but it's fine. We'll just, every single frame, we'll just update that text. And let's just see if it works, and then we'll delete it and replace it with something better. 5, 4, 3, 2, 1. Made it just in time. 0. Okay. Cool. Let's just get rid of it. I know you're looking at me like I'm mad, but I want icons. So in my HUD, I'm going to make a new UI. I'm going to make another panel, just in case I have multiple things in my HUD. Because this will make sense in a second. And the panel will be lives indicator. And we're going to add a component to this HUD called a horizontal layout group. Horizontal layout group. Then I'm going to add another item as a child of it that's just going to be an image, underscore UI image. And this is going to be life indicator, lives indicator and life indicator. And it will be a square, and it will be small, 20 by 20. And you can see it's positioned right there. But if I make more of them, they all automatically get moved to be in a row next to each other. And that's because of the horizontal layout group. What this game object does is it controls its children. And it moves them around. In this case, putting them run next to each other in a horizontal line. So child alignment, let's go with middle left. Ah, look, they all moved for me. And force expand, let's uncheck width. So now they don't take up all the space automatically. They just stack from the left. And spacing, we'll increase that till it looks okay. And padding, we'll pull ourselves away from the left. Fine. And now I can remove these child objects and add, Control D to duplicate, add these child objects, and they are going to be my visual indicator. So all I need to do is update how many children I have depending on my how many lives I have left. Right, I can delete them in any order. They're always gonna, that horizontal layer group is gonna move them around correctly. So we're gonna add a I don't need a panel here. Do I? I don't know, whatever. We're gonna add a new script called UI, a new C# script called UI lives indicator. Using that UI prefix for all my UI scripts. And what we're going to do is, should we get told what to do by the UI manager, or should we get a reference to the game manager ourselves? We can get a reference to the game manager ourselves. In awake game manager dot equals find object of type game manager. We've done that before. We're participating in something called the singleton pattern. We just don't know it yet, and we're not enforcing it. So we have a game manager, and now private int. Now we're going to check our code. So we're going to have a function that's going to refresh the number of children we have. Refresh children. And we need a prefab life indicator. So if the number of lives that are left has changed, I want to keep track of that. Well, I know how many children this game object has because of a very nifty function called child count. So I can check if transform.childCount is not equal to GameManager.LivesLeft, I can refresh children. And here I can add or remove the appropriate number of children. Well, if I need to add it, that's some piece of code. And if I need to remove children, that's another piece of code. And I don't want to do any of that. So we're just going to delete all children and then add all of them back. Which is fine. It's if we want to use the UI indicators to like do a little animation, deleting them and recreating them and playing animations and stuff gets a little annoying, and this wouldn't be a good solution, but this is a perfectly good solution for any list that updates instantly. So to delete all children, I'm going to just give you a nice bit of code here, a for each loop in our transform. If we loop through an object of type transform, that I'm using tab to hit these, it will loop through all of our children. Let me show you how I did that in Writer really quickly. I typed for each, and then I got this icon with this gray dots. And that's a template in Writer. And when I hit enter, that's going to give me these little blue squares and boxes, and I can hit tab and very quickly, and hit tab again very quickly. It'll walk me through all the parts, right? For I equals 0, I less than transform dot child count, right? And it just like brings me through everything. But what we're gonna do is we're gonna destroy our child. That's just the transform component, so we need to reference the game object that child has, and then now delete all children, add the right number back. For let's use the writer tool for, and then we got the little icon, simple for loop. Boom, I less than transform dot child count, instantiate our life indicator, and in the instantiate function, if I can set its parent, so we can take a look, and we can see that sorry, I'm like saving by reflex. Include an object. We can give it a position, an object of position and a rotation, which is what we've mostly been doing. But we can also just give it a parent. And if we make it ourselves, our own transform as the parent, then the then the lives indicator, the layout group, will manage the position of them all. So we can make this we can give ourselves the UI lives indicator. And now we just need a prefab. Let's make a folder in our prefabs, call it UI. And I'll call this UI life indicator. And we'll make that a prefab. And then we'll put that here. Delete these other ones. One exists in the scene. And delete that too. This should create them for us. But will it? No, it didn't. Because I'm looping through the number of children I have, and I don't have any children. I want to loop through the number of lives I want to display, which is the number of children I want. Yeah, add the right number of children back. Okay, less than game, start at 0, we go less than that number of times. Programming's hard, because that code looked fine. It passed the, glance test. Oh, I love it when the plan comes together. Let's change this color to green. Beautiful. Absolutely gorgeous. Our game manager, if we get rid of this canvas, nothing is broken. Our game manager does not have any dependencies on the UI manager or on anything else in the scene, right? The only place I have dependencies is other things need a game manager to exist. If we delete the game manager, the win script, the player movement script, it's gonna break. And I'm gonna get these null reference exceptions. So I need to have a game manager in my scene. I have created this condition that will my player can't move without a game manager. That dependency is why we hate the singleton pattern. It keeps things not compartmentalized. It has these dependencies. But while we're just getting started out, it's all right for us for now. Hold on, I gotta pause. I had to pause because I have a meeting in 15 minutes. So, you know what? Let's end this manager bit here, and I'll go to my meeting, come back, record part 3 where we do the level manager stuff, and then I'll end that video. That one will be very short, and then we'll do part 4, which was the original part 3. Will be the fun stuff that doesn't matter as much for the programming assignment. That's more about Unity stuff, like making our particle systems good. I won't bother with that. We'll just bring in some art assets and maybe. I don't know what I'm gonna do. I haven't decided yet. Sounds, something like that, but not the programming stuff, right? So here we made a game manager that cares about no one and nothing, and it just deals with itself and gets told all of its things from everyone else that's dependent on it, and they all can find the game manager. Because we know that there's only one, and we know that it's always in the scene. And we have if those two assumptions are true, then we're gonna be okay. We'll discover that turns out to be to kick us in the butt, but we're learning and we're going one step at a time in our code architecture. So it's allowed us to very easily make the canvas. I'll do one really quick thing. I will keep a private game state of currently displayed state, and currently displayed state, and we'll set it equal to playing, I guess. See, now we have this weird thing with initialization stuff that events would be fixing, but because it's not showing us the playing state, it's showing us some other state. And we'll check the state once on start, no matter what. And we'll set our currently displayed state when we update this. So now I have a quick, easy way to keep track of what state I'm showing on the screen. And now I can check only if my the state of the game manager is different than mine, this will no longer checks, this will update displayed state. It will refresh my UI. So only if the game manager state has changed, am I gonna do all of this stuff? So checking if in an enum is very fast. Doing all this code is probably much slower. So we'll do it once at start, and then we'll only do it when it's different. What we need to do it once it starts, so I could have maybe I'm going in and I'm adding stuff to my victory panel, but I want to be able to hit play and that goes away. And I'm currently showing the playing state. And now I play the win state, and it's much less laggy. I can feel it. I can feel that that was a important bug fix, right? We didn't do any profiling. We would have noticed that the check into state every frame was bad, but that was like, we actually hit the first time where we needed to optimize our code, and we could feel it. So no need to tell objects to run their enable functions or do whatever, check if they're all enabled and loop through the hierarchy and all sorts of slow stuff. Only do that as needed. Again, in the future, an event system is gonna help fix a lot of that trickiness, but we haven't learned it yet. So come back for part 3, which is required, part 2.5 of the level manager, and then later we'll just make the game more interesting for Unity learning's sake. So bye.